Okay, good morning, everyone, and welcome back to Math 115. Raj, let me put you in real quick.
Right.
Yep, no problem. Raj, where are you? There you are. Okay, so good morning, welcome back to Math 115. So today, we are going to talk about some new stuff, as usual. So we're talking about section 1.2 and 1.3 today. So that is going to finish up our discussion of circles from last time, and then we are going to get into the equations and graphs of lines. So that is what we're going to talk about today. Regarding the homework, there are two homeworks that I have assigned. So homework 1.1, which we finished 1.1 on yesterday, is going to be due on Thursday. And homework 1.2 I was going to set to be due on Friday, but then I realized there's absolutely no point to having it due on Friday when I could also give you the weekend. So I just want you to know I'm not trying to assign you homework on the weekend. My thought was that you could finish it probably by Friday, but if you want a couple extra days, I thought, hey, why not? So I put the due date for homework 1.2 to be Sunday. I'll probably assign a 1.3 homework as soon as we finish that section. So your next quiz is going to be tomorrow in class, the last 15 minutes of class. It will cover sections 8.4, 8.6, and 8.7. And I want to give a thank you to those who came to office hours yesterday. I think we had a good discussion of a lot of the content that is probably going to show up on the quiz. So if you can make it to office hours, that's a great way to study for quizzes. It's a great way to study for exams. I highly recommend it. So regarding those, of course, I'll again remind you that the time has changed and the location has changed. So they're now in person in LeConte on the 4th floor. My office is LeConte 439. We got a whiteboard in there. If we have a lot of people come, then we can move maybe into a classroom. What else did I want to say about that? Oh, yeah. The AC is still being tested in that building, so it's really cold in there for now. So you might want to bring a sweater if you come to office hours tomorrow. Any administrative questions from anyone before we start in on content for today? Okay, doesn't seem like there are any administrative questions, so let's get back into it. First, let me remind you what we talked about last time. So last time, we covered quite a bit of material, so let me take a minute to go over it again. So first, we introduced the coordinate plane, right? So in the coordinate plane, we basically arrange two real number lines, one in the upward direction and one in the rightward direction. And we call the horizontal one the x-axis and the vertical one the y-axis, okay? And the way we graph points on the plane is, of course, just by taking an ordered pair. The left coordinate tells us how far left or right to go, and then the right coordinate tells us how far up or down to go, with negative x coordinates being to the left and negative y coordinates being down. Okay, so that's how we think of negatives. And the next most natural thing to think of was, how do we understand distance in the coordinate plane? We have a good definition of distance on the real number line. We just take the absolute value of the difference of those 2 points. But what about when we have 2 dimensions? How do we do distance in 2D? Well, we use the Pythagorean theorem. Okay, so we use what we already know. We know how to find vertical distances, and we know how to find horizontal distances. So to find diagonal distances, we just use the good old Pythagorean theorem. So that had a formula, which is shown here. You can memorize it if you like, or you can always rederive it. We also learned about midpoints. So this was, how do we find the point which is equidistant from both of our 2 original points. So the midpoint is always going to be the point which it has equal distance from both of these 2 points here, okay, and is directly in between them. Another word that we might learn today to describe the midpoint is that it is also collinear. Okay, it is collinear to these 2 points, meaning that all 3 points lie on the same line. It might be a different line each time, but you can find a line that all 3 points lie on. Okay, so then we saw some examples of how to apply these formulas to actual numbers. It's basically just plug and chug. Then we talked about graphs. So wall of text here, we learned about the graph of an equation, which is of course the collection of all points x, y that satisfy the equation. Okay, so one way that you can try to graph it is you can pick some points to plug in for x and see what you get out for y. Okay, so that was how we plugged in some points here to find this parabola. And the way you check whether a point is on or not on the graph is simply by plugging in the x value for the x and plugging in the y value for the y. And if the equation is true, then we say yes, it's on the graph. If it's not true, then we say no, it's not on the graph. Third to last thing that we learned was intercepts, okay? So we learned how to find the points at which the graph intersects the y-axis or the x-axis, respectively. And the tricky thing about finding intercepts was that when we want to find x-intercepts, we are actually going to plug in 0 for y and then solve for x. When we find y-intercepts, we're going to plug in 0 for x. This is a typo here. We're going to plug in 0 for x and solve. Okay, so that's the tricky part about intercepts. And then we learned about symmetry. Okay, so symmetry just means that these graphs can be reflected about an axis, okay? Or if you want, the origin. So the way that works is we just check if for every point x, y, is the point negative x, y also on the graph? If so, then it's symmetric about the y-axis, and then we also have x comma negative y. If we have that, then it's symmetric about the x-axis, and then if we have negative x, negative y, then it was symmetric about the origin. So something like x cubed here is symmetric about the origin. Okay, so we learned how to test for these, and we did an example, and then we introduced the notion of circles. Okay, so we gave the definition of a circle, which was the set of points which are equidistant from a given center. And we learned the basic standard form of the equation of a circle. And it looks just like a Pythagorean theorem. This looks like a squared plus b squared equals c squared. Okay, of course, our c, in the case of a circle, is going to be the radius. And then x minus h is going to describe this distance. So let me show you. X minus h is going to describe this horizontal distance here, shown in red. And of course, y minus k is going to describe this vertical distance here. So if we have the triangle, we can always use the Pythagorean theorem to relate the side lengths of the triangle, as long as it is a right triangle. But it's always going to be a right triangle, isn't it? Because we're talking about a vertical line versus a horizontal line. These two things are perpendicular, which means they form a right angle when we put them together. So we can always use the Pythagorean theorem. And then we saw how to graph a circle from an equation. So that was a lot of stuff. Are there any questions over the content that we covered in class yesterday? Or any comments? Okay, what did you think was the most confusing part of class yesterday? Not that any of it was confusing to you, but just what was the trickiest part, maybe? You still asleep, maybe? Okay, come on. Some of it had to have been a little bit complicated, right? What about, like, testing for symmetry? Did any of us think that that was a little bit tricky? Or we have to plug in, we replace y with negative y, or we replace x with negative x, and we check if the equation's the same? Do we find that was a little bit annoying, Gavin? Yeah, okay, sweet. All right, so yeah, I think that maybe was one of the harder parts. I always encourage you all to think as we go about the parts which you find difficult, because that's going to be a great place to start when you're studying for the exam. Is remember, oh yes, when I was in lecture I was so confused by this one topic. That would be the perfect thing to come to office hours and say, I was confused by this topic, can we talk some more about it? So as you go along, check yourself and see, is this hard for me? Is this hard for me? If so, maybe make a note, write it down, put a star in your notebook or something, and come to office hours and talk to me about it. All right, I won't belabor that further, so let's get back to circles. So, of course, we have a circle with center h comma k, and radius r is related by this equation here. Okay, so what does that mean? That means that every single point on this circle, which you can see me drawing these little points with red on the circle, if I take the ordered pair, which represents that point, and I plug in the x value for the x here, and I plug in the y value for the y here, and I plug in this h here for h, and this k here for k, and this radius here for r, then the equation will be satisfied. Okay, this looks like a spider web at this point, but that is what it means to talk about the equation of a circle. So all of the points which are on the circle are the points which are shown in pink here, okay? So namely, if I plug in hk into this circle, okay, this point is not on the circle. It is the center of the circle, but it is not a point on the circle, because what would I get if I plugged in h comma k for x and y? I would get 0 plus 0 is equal to the radius, which definitely can't be true, right? Because the radius isn't 0. So let's see a new technique which is going to help us to get equations of circles into standard form, because this is a really nice form. It's super nice because I know exactly where the center is, and I know exactly what the radius is. So I can just draw it, basically, really easily when I have the equation in standard form. But what about if I have an equation which looks like this? Okay, it's not even immediately clear that the set of points which satisfy this equation is a circle, right? It's not even immediately clear. So we're going to learn a technique that is going to help us to figure that out, okay, which is called completing the square. Okay, and completing the square generally tends to be a technique that, in my past experience, a lot of students don't like completing the square, and it feels really unintuitive because we're used to taking equations and slowly making them more and more simple, okay? But what we're going to do in this case is we're going to temporarily make our equation a lot more complicated, and then we are going to simplify it in a nice way. Okay, so the idea is, if I have something like x squared plus a number times x, what I want to eventually obtain is a term which looks like x plus a number squared. Okay, I want to eventually obtain something like x plus a number squared. Okay, but if I have just x squared plus bx, there's no way that I'm going to be able to do that with factoring, right? Because if I factored this, what would I get? I just get x times x plus b, right? So that's not what I'm looking for. What I'm looking for is something like x plus something all squared, because that's the type of expression that I have in the standard form of a circle. So here's the trick. Okay, the trick is to do the following. We take the middle number, okay, b. So this number b, we're going to take that number and divide it by 2 and square it. Okay, so we take b over 2 squared. Okay, we take b over 2 squared. And then what are we going to do? I'm going to do nothing. Actually, I'm going to do something, but really I'm going to do nothing, because if I add something and I subtract something, if I subtract the same thing that I added, then I have not changed the original expression. So in principle, this expression and this one are equivalent, right? Because all I've done is taken the first one and added 0. If I add 0 to something, I haven't done anything, right? Okay, so I add and subtract b over 2 squared. Okay? Then, what I'm going to do is I'm going to leave this extra minus b over 2 squared alone. And what I'm going to do here is factor. Okay? So what do I need to do? I need to find a number such that if I multiply it with itself, I get b over 2 squared. And if I add it to itself, I get b. Right? Well, that number is clearly b over 2. Right? Because if I take b over 2 plus b over 2, what do I get? Just b, right? Which is the middle term here. Yes? And if I take b over 2 times b over 2, then I get b over 2 squared, which is this term, right? So this has the form of a perfect square, okay, where we're squaring x plus b over 2 squared. Okay, so this is the theory. Let's maybe see an example before we move to this circle thing. Let's see a quick example. Let's do x squared plus 6x. Our goal is complete the square. Okay, so what this theory says is if I have x squared plus a number times x, what I'm supposed to do is take that number, divide it by 2, and square it. Okay, so b over 2 is going to be 6 over 2, which is going to be 3. And therefore, b over 2 squared is going to be 9, right? So here's what I'm going to do. I'm going to rewrite x squared plus 6x as x squared plus 6x plus 9 minus 9. Okay, and this is the part that really messes with people because it feels really silly to do something like add 9 and subtract 9. Why are we making this more complicated than it needs to be? Well, that's because now if I look at just the first part, I can factor. How do I factor x squared plus 6 plus 9? I need to find a number which if I multiply it with itself, I get 9, and if I add it to itself, I get 6. What is that number? 3, right? So I can rewrite this as x plus 3. If you want, you could show it like this, times x plus 3. If I foiled this out, this is what I would get. And that is exactly x plus 3 squared minus 9. Okay, how do we feel about that example? Let's have thumbs. I need some feedback. Thumbs up if we feel like we could do that today if there was a pop quiz. Not that I would ever do that. I won't ever give pop quizzes, don't worry. Alright, that looks pretty good. So let's see how this is going to help us with this example. So why is completing the square important? Well, because it turns out that this actually is the equation of a circle, okay? This actually is the equation of a circle. But right now, it's not easy to see where is the center, okay? Where is the center and what is the radius? It's impossible to see just looking at it. Okay, so what are we going to do? Step 1 is going to be to group x's and y's and move numbers to the right. So sometimes instead of right side, I'll write RHS. And what I mean by RHS is right hand side. Okay, so let's go ahead and do step 1. Well, if I'm going to put the x's together, so x squared minus 6x. And I'm also going to leave a little bit of space here for me to complete the square. So then I'm going to have plus y squared plus 8y. And then equals negative 10. I should also leave a little space to complete the square for y. Okay, so now I have rewritten this, and I've grouped the x terms together, and I've grouped the y terms together. And now step 2 is going to be complete the square for both x and y. Okay, so let's copy that down and do step 2. So, who can tell me, what do I need to add? Well, let's start with the y. Why don't we start with the y? What do I need to add and subtract here in order to complete the square for y? What am I supposed to do when I complete the square? Very good. I take the middle term, 8, I divide it by 2, and square it. So 8 divided by 2 is 4. So 4 squared is 16. Okay, so I take the middle term, divide it by 2, and square it. So it's 16 that I need to add and subtract. Agree? All right. How about x squared minus 6? Well, I'm going to do the exact same thing, okay? I don't want anyone to be confused by the fact that we have a negative number here, right? We're just going to do the same deal, okay? I'm going to take negative 6, divide it by 2, and square it. If I take negative 6 divided by 2, I get what? Negative 3. And if I square negative 3, what do I get? Negative 9? No, positive 9. This is negative 3 squared, which is negative 3 times negative 3. The negatives cancel. I get 9. I am still going to add 9 and subtract 9 here. Okay, so now our goal here is to factor. Okay, we're going to factor each of these. So here's what I'm going to factor. This expression, and then I'm going to leave the minus 9, and then I'm also going to factor this expression, and I'm going to leave the minus 16. Okay, so let's factor the left-hand side. X squared minus 6x plus 9, how's that factor? Very good. X minus 3 squared. Okay. Now a plus sign comes. Actually a minus 9. And then now a plus. And how does the second highlighted term factor? It's going to be y. What should be the number which, if I multiply it with itself, I get 16. If I add it to itself, I get 8. That's 4, right? So this is a plus 4 squared, right? And then minus 16 equals to negative 10. Are we happy with this so far? Okay, so now we're getting closer to the form of an actual circle. What's left to handle? The numbers, right? Step 4, move extra numbers over. So these are the numbers which I created, which I have to pay for, right? If I buy a plus 9, I have to pay with a minus 9, right? So I need to deal with these extra numbers that I created. I'm going to do that by moving them to the right-hand side, and that's going to help me get my radius. So I move plus 9 and plus 16 over to the other side, and I'm left with x minus 3 squared plus y plus 4 squared is equal to, what, negative 10 plus 9 plus 16, which is negative 10 plus 25, which is 15, I think, right? All right, so we've got this into... Sorry?
X minus 3 squared minus 9, shouldn't that be a plus 9?
Sorry, where at?
At, like, under step 3 factor.
Are you talking about right here?
I feel like I missed something. I don't know.
Okay, so here's why. No, I agree. This is the more confusing one, right? Why is it more confusing? Because it has a negative in the middle, right? But the thing is, we're creating a perfect square here. So even though I have a negative here, when I multiply it by itself, I get negative 3 times negative 3. That's responsible for this plus 9, right? So this term here is exactly equal to this term here. So I leave the minus 9 there. Is that more clear now?
Yeah.
Okay. Yeah. So, I've got x minus 3 plus y plus 4 all squared is equal to 15. So let's go ahead and I'm going to retcon this and add some directions here. And graph. Let's graph it. Okay, so what is the center of my circle? This is a trick question, by the way. We got to be careful. What do I need to be careful about? It's 3, negative 4. Okay, this is the center. It's going to be 3, comma, negative 4. All right? Remember, in the standard form, it's x minus h and y minus k. Right? So I have to be a little careful about where the center is going to be. It's going to be the negatives of these two. Okay? And how about my radius? Is my radius just 15? No. What is my radius? The square root of 15. Very good. So let's graph it. Okay, so 3, comma, negative 4. What quadrant is the center going to be in? Quadrant 4, right? Because we're going to move to the right and down. So 1, 2, 3, 1, 2, 3, 4. Here's where the center is. Okay, and how am I going to draw a radius which is square root of 15 if I don't have a calculator? How am I supposed to deal with that? Give up? Give up? Okay. No, we don't want to give up. We want to do our best. Okay, but the trick for something like the square root of 15 that I like to use is that it should be... We can have an idea of roughly what it is, okay, in the following way. I think that you would agree that square root of 15 is larger than the square root of 9, yes? But smaller than the square root of 16. Agree? And the square root of 16 is 4, and the square root of 9 is 3. So the square root of 15 is going to be somewhere between 3 and 4, right? And probably a lot closer to 4, because it's 15, which is pretty close to 16. So I'm going to draw a radius that's like, I mean, it doesn't have to be perfect, but it's going to be close to 4 units. Okay, so if I were to do a radius of exactly 4 units, that would be 1, 2, 3, 4. I'm going to do a radius which looks like a little bit less than that, maybe to like right here. And then I'm going to draw a circle. which looks something like that. Of course, I haven't drawn this very well in terms of my points are not to scale. Probably this edge should be over to the other side, right? Since this is just 3 units. But anyways, it's not to scale. We did the best we could. Okay, so that's how we could try to graph this circle. A lot of moving parts here. We got to start with our standard form equation, and then we have to complete the square not once but twice. And then we still have to simplify a little bit and get our center and our radius and graph it. It's understandable if you're overwhelmed. So what I'd like to do is a practice problem. Okay, we're going to do a little bit of group work here, so I'd like you to partner up and work on replicating this process with this, I think, slightly easier one. Maybe it's not easier. We'll see. So we want to find the equation in standard form. List center and radius. Then graph. All right, so go ahead and work with a partner. I'll be walking around. If you need a little help, just call me over. Well, okay, so I like this first step, of course, so okay, we group the terms, although of course we probably want y squared to come before minus 2y, you see what I mean? So we probably want x squared minus 2x and then y squared minus 2y, right? So let's fix that, and let's also move over onto the other side. So y squared minus 2y is all equal to 4. Okay, very good. So, like you said, you want to take that middle term, which in this case is negative 2. We take that number and divide it by 2. What do I get if I take negative 2 divided by 2? I get negative 1, right? And then what am I supposed to do with that number? Right. So negative 1 times negative 1 is 1. So what do I need to add and subtract? And do plus 1 and minus 1. We still have minus 2x. X squared minus 2x plus 1 and minus 1. And the other one's kind of the same, right? Because it's a negative 2 again. So we're going to have then plus y squared
So would it be somewhere between
minus 2y and then y.
like almost like 2.5
Exactly, plus 1. It's all equal to 4. And now our goal is factor this guy and this guy. And then the negative ones are going to go to the right side. Okay.
I know.
But like start from here. This expression. Factors. Then take this expression. And x squared is 2x. So how does x squared minus 2x plus 1? Adds to the negative 1 is negative 1, right? So that's x minus 1 is not x minus 1, right? Which is x minus 1 squared. So all that's not and of course I still have my minus 1. And then I've got plus y minus 1, y minus 1. I'm going to take these minus 1 to the other side. And I'm going to write the left hand side x minus 1 squared plus y minus 1 squared is equal to 11. So if it's minus on this side, how do I get to the other side? I add it, so I get 3, right? All right, can I have a show of hands if you need a little more time to work still? Okay, take maybe another minute or two, okay? All right, let's come back together as a group here and try this one together. So how was this one? Tricky or not so tricky? What do you think? Not too tricky? Little tricky? Okay. I always like to practice when I see these types of problems and imagine before I start the problem what might give me difficulty. That often I feel like helps me to foresee what I'm going to need to be a little careful with. In my opinion, when I first see this, I'm a little bit wary of the fact that I have minus signs in my complete the square. And I got to remember, okay, when I'm doing minus signs, I divide by 2, but if I square a negative, then I get a positive. And it's just a little harder than if it's all pluses, right? We all love doing addition and hate doing subtraction. So let's go ahead and start by grouping, like how we normally group. And then I'll add y squared. And I'll subtract 2y. And then equals to net positive 4, right? Okay, who can help me out with the next step? What should I do next? Okay, Liv says we should take this middle term, divide it by 2 and square it. I like that idea. If I do negative 2 divided by 2 and square it, what do I get? Well, negative 2 divided by 2, that's negative 1. What do I get if I do negative 1 times negative 1? Positive 1, right? So this is 1. So I need to add and subtract 1. And one thing that you might notice is that the one on the right side is not the right-hand side, but the one with the y's is basically the same as the one with the x's, right? Because it's a minus 2 in the middle again. So I'm going to do again, plus 1, minus 1. Okay, so I just made this look a lot more complicated than it did before. Why does this help me? Because now I can factor. That's exactly right. So the ones I'm going to factor are this one and this one, right? I'm going to factor. So I get, what do I get when I factor x squared minus 2x plus 1? Very good. X minus 1 squared. If you need to have a middle step where you factor it like this, x minus 1 and then x minus 1, that's fine. But you can also see that it's going to be x minus 1 squared. And then I have a minus 1 still, and then plus y minus 1 squared, right? And then minus 1 is equal to 4. Okay, am I all done? That's right, we got to move negative 1 over to the other side. So I get x minus 1 squared plus y minus 1 squared is equal to 6, right? Okay, so what's the center of my circle going to be? Very good. 1, 1. Okay, be careful. Just because we have a minus 1 here, the center is actually going to be at positive 1. Positive 1. Okay? And then how about the radius? Square root of 6. Very good. And, okay, let's go ahead and draw. So center's at 1, 1. And the radius should be the square root of 6. What do we think about the square root of 6? Someone give me like an approximation if they don't have a calculator. How would I figure out an approximation for the square root of 6? Yeah, it's between 2 and 3. It's bigger than square root 4, but it's smaller than square root 9. So I'm going to do something like, I don't know, 2.5 maybe. Okay, so I need to go 2 units and then a little bit more. So here's 1 unit. Okay, maybe I should put a thing here. So that's 2 units. And then I go a little bit past 2 units. And then I'm going to draw my circle, which looks something like that. And I gotta make it bigger, right? Not smaller. Okay, so that could be my circle. All right. Do you feel a little bit better after trying this on your own? Okay, that's good. That's why I like to incorporate some group work here and there. And that's also, by the way, why the homework will help you to learn. Okay, any questions on circles and completing the square? All right, it doesn't seem like there are any questions on that. So let's move on and talk a little bit about lines. Okay, so we're entering into section 1.3 here. I'm trying to catch up with myself a little bit because I'm a bit behind. So let's talk about lines. Well, I think we all have a intuitive understanding probably of what lines are just because, I mean, maybe when you're like 3 years old, you learn how to draw a line or something like that. So what are they? Well, it's a collection of points which all go in I don't even know how to describe a line without using the word line. But they all go in a straight line, right? Okay, so what does that mean specifically? It means that we obey a specific format of how steeply we are going to rise, okay? How steeply we are going to rise. All right, so that steepness, okay, is what we call the slope of a line, okay? And the way we find it, okay, is using our good old rise over run, okay? I expect rise over run is probably very familiar to all of you. So how do we actually compute the slope of a line if we know 2 points that are on it? Well, the rise is, of course, going to be the vertical leg of this triangle, right? The vertical leg of this triangle is going to be the rise, which is given by y2 minus y1. And then we can, of course, divide that by the run, which is going to be the horizontal leg of this triangle, which is x2 minus x1. And by the way, it doesn't matter if I do y2 minus y1 over x2 minus x1 or y1 minus y2 divided by x1 minus x2. Oh, that's kind of funny. Doesn't this seem like it should be the reverse of that? Those two things seem like opposites, don't they? Why are these two things equal to one another, even though I swapped the order? I'm just trying to find the difference between these two numbers, but let's think about it in a more concrete way. Why is let's do some examples. I think it might be easier if we use an actual number. Let's do 2 minus 1 divided by 3 minus 2. What would I get? I'd get 1 divided by 1, right? What if I did 1 minus 2 divided by 2 minus 3? What would I get? Negative 1 divided by negative 1. So the reason that it's okay to do this in any order is because if I accidentally created something in the numerator, like a negative in the numerator, I'm also simultaneously creating a negative in the denominator, which cancels out. So these two things are all equal to one another. What's important is that you don't mix and match coordinates from one and the other. Okay, so I don't want to do x2 and y1 and then y2 and x1. That would be bad. Okay, so that's how we find the slope of a line. Okay, so if we have a positive slope, then our number m here is going to be positive, and the line increases from left to right. Okay, so the one shown here has a positive slope. Okay, so the way you can think about it is if I was a little dude walking in a rightward direction, the question is, would I be walking uphill or would I be walking downhill? Okay, so the line increases from left to right. That's what it means to have a positive slope. If we have a negative slope, then that means that m is less than 0. And then the line is going to decrease from left to right. So let me draw a picture of what that would look like. A negative slope would look like this, maybe. Okay, so that's the difference between positive and negative slopes. So we'll call it there for today, and we'll talk more about lines next time. I'll see you tomorrow.